Hey, what's up everybody? I'd like to welcome you to another JUCE tutorial. And in this tutorial, we're going to go over the audio processor value tree state. So this is what we need to use if we want to properly relay values from our UI that the user is changing when they're changing parameters over to the plugin processor where we're actually doing our DSP. This is going to be quite a lengthy tutorial because we have to do quite a bit of typing, but I hope you can follow along. Also, be sure to support us with the Patreon on patreon.com/theaudioprogrammer, and check out our merchandise below at Teespring. Right below this video, we have mugs, hoodies, t-shirts, and more. So let's go ahead and get started. This is going to be a lengthy video, and we're just going to jump right into it. So the first thing that we're going to need to do is have a look at the audio processor value tree state class. So this is an object that will essentially hold all of our parameters for our plugin. So all of this stuff that we have in our sampler, we have this attack, decay, sustain, and release that we're using for our ADSR parameters, and we're going to be getting values from our sliders and storing those in our value tree so that we can properly also store states at a later point and load them if we want to have presets where we have different presets with different ADSR settings. So the first thing that we need to do is create an audio processor value tree state object. So I will do this here. So audio processor value tree state. Okay. And now we will see, if we scroll down a little bit, we have a couple different types of constructors that we could call. It says that this one that's more simple to use is discouraged and will be deprecated. So we need to use this audio processor value tree state constructor right here, and we need to declare it using an initializer list. So the way that we do that is we go up to our constructor and we can just go over here to where our last item in our initializer list is, and we can just call our audio processor value tree state object. I'm just going to paste these arguments in here, and we can go through those one by one. So the first thing that we need is the processor to connect to. So the processor that we're connecting to is our Hello Sampler audio processor. So that's where we will just dereference this keyword. So this refers to this actual audio processor. We aren't going to worry about undo manager, so we could just put null pointer there for that. The identifier is basically a string that refers to, if we need to at some later point refer to this particular value tree, and I will just call this parameters. And then this parameter layout object that we need, if we go in here, we will see that we have this parameter layout that contains the set of audio parameters that we're using for our plugin. So if we go in here, so this can be a little bit complicated to lay out, but I'm going to show you how to do this. So the first thing that we need to do, the easiest way that we could do this is we could actually just create a parameter layout function that returns a parameter layout. So what I'll do is I will create a function that's called audio processor value tree state parameter layout, and I'll call this create parameters. Okay, and now we can go ahead and implement this down here. So we will go audio processor value tree state, create, what did I call it? Create parameters. Oh, I'm sorry. So we are returning an audio processor value tree state parameter layout, and then we need to call our processor because that's the class that we're in, and then the function is called create parameters. And in here, so now we have a function that will at the end return an audio processor value tree state parameter layout. And so what I could do is in here I can just say call the function create parameters. Okay, so now going down here, let's take a look at the documentation. So this can be a little bit daunting to read if you're just getting started, but I'm just going to walk you through it piece by piece. So the first thing that we want is we want a vector of unique pointers of ranged parameters. Okay, so I'll show you how to do this. Also, it's helpful in the audio processor value tree state. If I can find it. Let's go back to it. In here, there's also some helpful documentation here that shows you the basics of how to do this. So in here, we will create a vector of type unique pointers of type. And then what we can do is, I'm going to open a couple windows here. We have what's called ranged audio parameters. So these are just kind of a generic object that refers to some of the different types of things that we could do with our parameters. So we have a bool where we can turn something on or off. We have a choice where we could choose between a couple different options. And then we have an audio parameter float, which is what we need because we have our ADSR, which is going, in these decimal ranges between 0 and 1 or 0 and 5 and so on. So what we want is ranged audio parameters, and then we will just call these parameters. And then what we want to do is we want to create a few of these, and we will put them, and then at the end what we can do is we can return the parameters from beginning to end, like so. All right, so just need a semicolon there. So now all we need to do, this is where we actually create our parameters for that we're going to get from our slider values. Okay, so we're going to get rid of the slider listener class here eventually, but let's take a look here. So the first thing that we need to do is we need to do a pushback, which is parameters.pushback. So what we'll do is we'll push back a new ranged audio parameter. So we will say, so we need to allocate some memory here for our unique pointer. So that's why we're using make unique. And then here we will do audio parameter float, because we're creating a float, which is the type of parameter that our attack, decay, sustain, and release are. And then in here, if we go to the audio parameter float documentation, we will see we can call this one where it's like it's got loads of different arguments, loads of different customization that we could do. I'm just going to call this simple one here. Okay, so that's what I'm going to use here. So here's where we put in our arguments. So parameter ID is what normally in caps. So I'm just going to call this attack. Then the parameter name is normally what you would see in a DAW. So I'll just call this attack just with one capital. Then here we put in our range. So this will be 0.0, and then we'll make our max 5.0, and then we'll make our default 0.0. So we'll make it attack quickly. And I think I've got an extra parentheses there. So that's how we do that. And now let's just do the same thing for decay, sustain, and release. So now we have sustain, or actually, I'm sorry, I'm going to do decay, and then decay, and I don't know, I guess we'll do same sort of thing. I'll maybe make it 3 seconds, maybe make the default 2, and then we'll do sustain. Then once again here, and then this is normally 0 to 1, and we will make the default 1, and then we have release, and then release. And then this will go, we could go 0 to 5, and we'll make the default for this 2. Okay, so what we've done is we've just created 4 new parameters that we're putting in our audio processor value tree state. Now they're not associated yet with our sliders in our editor, but that's what we're going to do next. So remember, we're calling create parameters, and then what we're doing is we're then calling that when we initialize our audio processor value tree state. Okay, so now what we need to do is we need to associate those with these sliders that we created a couple tutorials back. So let's go ahead and do that. So first thing, let's get rid of our slider listener class. We don't need that anymore. So I'm going to get rid of it. I'm going to stop inheriting from slider listener. I'm also going to get rid of this method slider value changed. Okay, because we don't need that. And then I'm going to go down here, and we have all of this code that we did in slider value change. We're now going to get rid of it because we're going to do something better. Okay, so once we did that, once we got rid of the slider listener, we'll see errors here that say, hey, add listener, you don't have a listener anymore. So now we get rid of all this code for adding the listener. Okay, so now we're looking good. So now what we need to do is we have this audio processor value tree state, which is in one of these tabs. Now what we need to do is we need to associate what is the parameters that we've created on the processor with the actual sliders that we created. So since we have sliders, in this case, we're going to use the audio processor value tree state slider attachment. Okay, so now we have these slider attachments, and then we can see when we want to create one, we have the state that we want to control. So that's our audio processor value tree state object. We want to go to the ID. So those are the attack, decay, sustain, and release parameters that we created. So if we scroll down, we have these parameter IDs here: attack, decay, sustain, and release. And then we say, okay, we want that parameter to be controlled by this slider, and that's where we put the appropriate sliders. Okay, so let's go ahead and start. So we will make these unique pointers. So this is audio processor value tree state slider attachment. So it's a unique pointer of type audio processor value tree state slider attachment, and I will call this attack attachment. Okay, and now I'm just going to do the same thing for decay, sustain, and release. Okay, so here we are. And now what we can do, we can actually, funny enough, is we have this set range. And what we could do is we could get rid of these now, because the value tree will actually relay what the range of the parameters are. So here we have our attack parameters, and then what we could do, so now we want to call our attack attachment, which is our slider attachment. And now what we want to do is, this is where we actually allocate some memory on the heap, where we say stood, make unique. And then this is an audio processor value tree state slider attachment. And then in here, this is where we need to call our arguments here. So I'm just going to paste those in here for us. So we have the state to control, which is our audio processor value tree state. So we got one little thing in here that our audio processor value tree state is in private. You could make it public. I like to do it like this. I like to know what I'm giving access to here. So I'm going to create a reference to the audio processor value tree state object and get APVTS. And then I'm going to return MAPVTS. Okay. So rather than making this public, what I'll do is I'll just use a getter to actually give access to that. So now what I can do over here is I could say processor, because remember we have this reference to our processor, right? That's how we access, that's how we can access member variables in our processor. So I can say processor, sorry, I think I need to click in here. So I can say processor dot get APVTS, and that gives us our audio processor value tree state. Now we have this parameter ID, which is the string that we want to get. So this is the parameter that we're actually trying to grab, which is going to be attack. Okay, so just to review, we have that parameter ID, which is called attack, and we created that here, okay, in our parameters list here, where we've created attack, decay, sustain, and release. So all we're doing is we're just saying, hey, we want this slider to be associated with this parameter that we've created here, and create parameters that we've put into our value tree. Okay, and then this is what we're saying. We're saying, okay, we got this parameter, we're calling it attack, and now we're associating that with our attack slider. Okay, this is formatted a bit funny for me here. So sorry about this. I think that's an extra one. Just going to bring this back. Okay, so that's how we do that. So now we just need to do the same thing for decay, sustain, and release. Okay, so like I said, this is a bit of typing. Okay, but this is what gets us to where we want to go. And this is our decay slider. Then we do the same thing for, make sure you change this as well, because we have decay attachment, sustain attachment, and then this is sustain, And then we have our release attachment. Okay. Okay, so now we should be good. Now what we need to do is, so now those are connected up, okay? Sort of. Now what we need to do is we need to actually be able, let's see here. So now we need a place where we can actually take the parameters. So at the moment we have the slider parameter, or the slider values that are going into our value tree. So now we need to connect the value tree with our ADSR parameters. Okay, so the natural place to do that would be in our update ADSR function. So this is, so what we could say is, so we have our, let's see, ADSR params. So that's where we're actually resetting all of this. So we go MADSR params attack equals, now we just need to get this value back. Okay, so we could say MAPVTS, and then we could use the function called get raw parameter value. So let me just go back a step there because I want to show you something. So this returns a stood atomic float pointer. Okay, so now we just want to get that back. So it's a little bit tricky to get that back, but I'm going to show you how to do it. So this gets the pointer, and then now what I could do is I could use the load method. So load is a method in the stood atomic class. So stood atomic is from the standard library, and load is what actually gets us the value of this attack. So that's what actually gives us the number. Okay, so now we could do the same thing for decay, sustain, and release. Get raw parameter value, and then decay. Oops, sorry. Decay. And then we're using the arrow operator because this is get raw parameter value, once again, is returning a stood atomic float pointer. Okay, and because it's a pointer, that's why we got to use that arrow operator there, and we use load to actually give us the value back. And then we got sustain, and we got get raw parameter value, sustain, and then load, and then we do the same thing for release. Get raw parameter value, release, load. Okay, so that's how we're actually connecting. So we have the sliders that are connecting with the value tree. Then the value tree is connecting with the ADSR, and then we're updating our ADSR parameters. Okay, so that's how we're calling that. Now, another thing that we need to think about is we don't have a way to update our ADSR now, because before we had our slider listener class that listened for any changes that were happening in the slider, and anytime we were making any changes in any of the sliders, it would call this update ADSR. Okay, so now what we'll do for now, right, we'll adapt this later, is we will say update ADSR. Okay, and that's going to update every audio callback. Every time this process block calls, that's going to update the ADSR. Now we don't want to do that every callback, so we're going to use something else, okay, to actually monitor when we're actually making changes, and then we're going to call we're going to listen for any changes in our value tree, and when there's a change in the value tree, that's when we're going to call update parameters. So going back here, we can go back to the JUCE documentation, and we actually have this value tree listener class. Okay, so this listens for events that happen to a value tree. Okay, now the only thing that, so we have these methods that we can override here. So we have the only one that we need to worry about is value tree property changed. Okay, so this, and it says this method is called when a property of this tree is changed. So anytime that something has changed in the tree, it will call value tree property changed. So now all we need to do is just override this method. Okay, so we're just going to use that. So going back down here, we can say void, and then I'm going to paste this, and then I'm going to call it override, and then I need to inherit. So this is so what we want to do is we want to inherit the value tree listener class. Okay, so we will say public value tree listener. Okay, get our formatting right. And now that error should go away. Okay, I'm not going to wait for it to go away, but that's what it should happen. Now what we need to do is we need to register the value tree listener and associate that with our audio processor value tree state. So the way that we could do that is using APVTS, and then what we need to do, so the audio processor value tree state and the value tree are two different things. Okay, so the audio processor value tree state contains the value tree. Okay, so very easy to get those mixed up, but they're actually two slightly different things. So if we go back into the APVTS, wherever it is, okay, I'm just going to call it, here we go. And we have this, so to get to the state, to the value tree object, we actually have to call the state. So it's audio processor value tree state dot state. Okay, so that's audio processor value tree state dot state, and then we have this method called add listener. Okay, and that's where we add this component as a listener. So we want to listen to changes that are happening in the value tree that's inside this processor. Okay, that's why we're doing it like that. Okay, so we're listening for changes in our value tree in this processor. So now what we want to do is we want to I'm just going to fix my formatting here. We want to actually implement this function now. Okay, so going down, and what I could say is void hello sampler audio processor value tree, what's it called again? Value tree property changed. Property changed. Okay, and then here, this will call anytime our a value has changed in our value tree. So anytime that our user modifies any of the parameters in their UI that is connected to our audio processor value tree state, it will call value property changed. Okay, so I'm just going to fix this again. Okay, so now what we can say is if something changes in our value tree, we want to update. Okay, so what we could do is we could create a variable. So what I'm going to do is I'm going to create an atomic Boolean variable called should update. Okay, and then I'm going to set it to false. Okay, so if you don't know what stood atomic is, it's quite important for audio processing. So this is an atomic variable, is a type of protection that we can use in our audio callback, where if we're trying to change, let's say that we were trying to read whether should update is true or false, but at the same time we had something else from another thread that was trying to change it, there could be a conflict there. Okay, and atomic helps us prevent those type of conditions. Okay, so it's something you should definitely read up on. So if I said, let's see, let's go back a step, right? So I have this function where value tree property is changed, and I want to say, okay, when that happens, we should update. Okay, and then up here, where are we? In our process block, we want to say, if we want to update, then we want to update, then update our parameters. Okay, or else it's just going to continue just to run through the process block. Okay, so that's how that works. Okay, so let's just compile this and see if this actually works. So it looks like I'm missing, I've messed something up. Oh, this right here. So I should put this here. And now let's try again. So now we're compiling, and we are going to put this in here. So now we have our plugin. As we can see, so our parameters are 0, 2, 1, and something else. So we see that the values actually relayed from our what's it called? Sorry, from our value tree over to the sliders to give them their values, even though this is weird. I'm not sure what's happening here in release. Let's have a look and see what's happened there. So this should be 0 to 5 and 2. And then let's look at our editor. So I must have messed something up. So we see here that I've got a lowercase e. So that's messed us up there. So I'm going to compile this again. And here we go. And then here we are. So now you can see that the parameters have initialized properly. Okay. Now let's see if they have actually gone through to our ADSR properly. So I'm just going to turn this down a little bit. So we can hear right away that this should be 0.0, but we hear that it's not attacking right away. But if I click in here, now we can hear that the attack is where it should be. Okay, so it hasn't quite initialized properly, but we can see that the ADSR is working, right? So we see that we got some release there. And if I turn the sustain down, the decay down, right? Or if I turn the attack up, we see that that all works properly. We just need it to get it to initialize properly. Okay, so that should be a relatively easy fix. So all we need to do is call update. Well, let's go back to our processor. We just need to call update ADSR in. So we called it. So we called it in prepare to play. Oh, what we need to do. So what we need is when we load a file, that's when we need to update the actual ADSR to let it know, hey, these are the parameters we want it to play with. This should work, hopefully. I would hate to have to do this video all over again. So let's hope that it works. Okay, so here we are, going back in here, and now we have this, and now let's go back to our synth sound, if I can find it quickly, not waste too much time. Okay, here we are. Now it should attack right away. Yes, so we hear that it attacks right away, so it's working now. Okay, we see that the waveform disappears. Okay, it repaints and then it colors it all black. Okay, so that's something that we'll have to fix in the future, but we can see that the ADSR is working properly. And another exciting thing that we can see, if we go over here and if I click on automation, so now we have automated parameters. So if I go to Hello Sampler, now we have our parameters here. So this is the reason why we're doing the value tree, is because then what we can do is we can automate these parameters. Okay, and they work. Even though I'm not pressing any MIDI notes, okay, I'm not going to waste time on that. But you see, that's how we get the automation. So it actually looks into the value tree and it's actually able to make the automation. So that's how we're able to do that. Okay, so value trees for the win. So I hope you enjoyed this tutorial. I know it's a little bit complicated, but and it took me quite a long time to get some of the syntax down myself in terms of knowing what to do when it comes to stuff like pulling like atomic values, finding out what the value of an atomic is, what an atomic is, stuff like unique pointers, and when some of these things get a little bit longer, like we have these stood, unique pointer, audio processor, value tree, state, slider attachments, so these sort of things, they take a little bit of time to get to know, but just hang with it. If you've got questions or you get stuck, just leave a comment below, or you could join our Discord community. It's completely free. We have audio developers from all around the world that can help out with problems like this. And when I'm in there, I can try to help out the best I can. And you just have to persevere, but you will get there. Okay, I remember a year ago, I didn't even, it took me so long just to really understand exactly what some of this stuff was doing, even though I was trying to do it. So just stick with it, okay? And I hope you enjoyed this tutorial and found it helpful, and I will see you next time.